Okay, we're going to start talking about 1.3, solving literal equations. Literal equations are just regular equations like we've been solving, only they're mostly variables. One reason we solve literal equations is to solve for y, to be able to graph, to get it in slope-intercept form, y equals mx plus b, instead of standard form like this, which is much more difficult to graph. We can't see our slope, we can't see our y-intercept. And we'll get into that more later. Also, it makes it easier to substitute into a table. For instance, if I substitute 1 into this equation, I still have to solve for t. But if I rearrange the equation first, then I can plug 1 in here and take 1 divided by 4.5 to get t. And then take 2 divided by 4.5 to get t. And then 3, and so on. It makes it a lot quicker and easier to fill in a table. It's also very handy in science classes when you need to convert from one thing to the other. Sometimes you need to change the way the equation's arranged. So the first one we're going to look at is distance equals rate times time. It's wanting us to solve for rate. So to get that piece by itself, I have to think about what operation is here. So this is r times t. So to get that by itself, I'm going to divide by t. And now I have d over t equals r. So that is finished. I got r by itself. That's all it's asking you to do. Okay, you're just wanting to isolate whichever variable they tell you to solve for. So on the next one it wants me to solve for h. I want to get this piece by itself. All 3 of these pieces are touching by multiplication. So to undo the multiplication, I'm going to divide. So I get v over L times W equals h. And that is my answer. That is completely finished. I'm done because h is by itself. Okay. And on the third example here, it wants me to solve for a. I want to get this piece all by itself. So here I have to think about, these are addition. So to get rid of addition, to undo addition, we subtract. So maybe I'll start by subtracting c to the other side. So that gives me p minus c equals a plus b. I still want a by itself. So to get rid of the plus b, I'm going to subtract b. So I have p minus c minus b. I can't combine any of these because these are all different. So I just leave it the way it is. And there's my final answer. All right. Now let's move on and see if we can try one that's a little bit harder. So looking at some 2-step, I want to get b by itself. Here's b up here. But this is whatever's touching it right here. That's going to be the hardest to get rid of. So we're going to start by getting rid of this denominator. So I have divided by 2. To get rid of divided by 2, I need to multiply by 2. So it's going to give me 2a equals b times h. Once you have that gone, these 2 are touching by multiplication. All I need to do is divide. And I'm going to divide by h because I want b by itself. These cancel, and I have b equals 2a divided by h for a final answer. All right, next one wants me to solve for w, so here's my w. Start by getting rid of whatever's not touching it directly first, just like we do on our regular 2-step equations. So to get rid of the 2l, I'm going to subtract 2l. Whatever I do on one side, I do on the other. These are not the same variable, so I can't combine them, so I just write p minus 2l equals 2w. Okay, then I still want w by itself. These are touching by multiplication, so to get it by itself, I'm going to divide. So my final answer is w equals p minus 2l over 2. All right, one more 2-step equation. We want to solve for y this time. Here's y right here. So I'm going to move this piece first. I have a positive 3x, so to move it, I'm going to subtract 3x. Whatever I do on one side, I do on the other. Gives me negative 4y equals, here these are not the same. They don't have the same variable. This one doesn't have a variable at all. So I have to write 12 minus 3x. Then these are touching my multiplication. So I'm going to divide by negative 4. Divide by negative 4. And my final answer is y equals 12 minus 3x over negative 4. There we go. You can also rewrite that. You could simplify it by dividing each one of these out. So this would also be an acceptable answer. You could say 12 divided by negative 4 is negative 3. And then negative 3x divided by negative 4 is positive 3/4 x. This is exactly the same. Either one of these would work. All right. Moving down to our last section. Here's some multi-step ones. Here we have I equals v over r. We want to get r by itself. So here I have division. To undo division, I multiply. This one's a little strange because what we're looking for is on the bottom. So when I multiply, I'm not done. I have I times r equals v now. Still want r by itself. Now these are touching my multiplication, so all I have to do is divide. So this is really just still a two-step equation. It's just that we're not used to having to get whatever's on the bottom here by itself, but sometimes it happens. And there's my final answer. Okay, in our last example, we want to solve for f. Here's f, but it's a little hard to get to. We have these parentheses, and we can distribute, or we can just get rid of the 5/9 to start with. So to get rid of the 5/9, we're going to multiply by 9/5. Whatever you do on one side, you have to do on the other. So that gives me 9/5 c equals, if this cancels out, then all I'm left with over here is f minus 32. I want to get f by itself, so I'm going to add 32 to both sides. These are not like terms. I cannot put them together. So I have 9/5 c plus 32 equals f. There we go. Now I have solved for f, and I can easily plug in a Fahrenheit or a Celsius temperature and get my Fahrenheit temperature. So this is one that you may actually use frequently in a science class. All right, well, that is all there is to 1.3. Please feel free to ask me any questions.